Oh, welcome and thank you for joining. Let's take a look at another exponential equation. This one is quite interesting, and what makes it special is the fact that we have variables in the exponent and in the base. Quite interesting, isn't it? So, how would you approach that? So, whenever we have variables tangled together very tightly in one term, the first thing that should go to our mind is separate them. Separate them so that you can access them, more easily, break them. So, how can you separate the exponent then from the base? So, for this, we can use what we call the power law of logarithms. Remember that if we have the log with base a, of some number b to the power of x, then that would be equal to x times log with base a of b, which means that the power will come to the front, become a coefficient. So in this case, since we are dealing with an equation, we can apply the same transformations to both sides and still create the same or obtain the same equation with the same solutions. So we'll take the log of both sides. Now remember that you can take the log with base 10, the log with base 2, the log with base e, or should I say the ln, so it doesn't really matter. So in this case, I'm just going to go for the regular log with base 10, so the same that the calculator provides. So I will take the log, and base 10, we don't really have to write it. I will write it only in the first step in here as a reminder of, what logs we're working with here. Okay, but when the base is 10 is that when we don't write it. It's the same as when we have a term to the power of 1, we don't write the power, so we assume and we know is 1. The same thing with log. So if you have log with base 10, that's simply log. Okay, so applying the power law here, we're going to have x plus 2 become a coefficient, multiplying log of x squared minus x minus 1. Now, the term on the right side is numerical, which means we can find the value of it. You can estimate it in your head. You know that this is one of the log properties. Whenever you see number 1 inside a log, it means that the value of it, of the entire term, is 0. Or if you've forgotten the property, you can simply use the calculator and ask the calculator what log of 1 is. And if you forgot this as well, you can just break it down into change your base formula and calculate it. So same idea. So we have 0 here. And let's take another look at our equation now. And let's look at the equation from a fresher perspective because it has changed its look and it's got a makeover. So what we have in here is two things multiplying each other, and these two things multiplied together are giving us 0, which means that this equation is in factored form already. And all we have to do is make each factor equal to 0 to discover the solution. So we're going to say either x plus 2 is 0 or the log of x squared minus x minus 1 equals 0. Let's see what this turns into. I love the first equation. It's so easy to solve. It's linear. X equals negative 2. So I created the first solution already. Beautiful. Now let's take a look at the second equation here. We have log of x squared minus x minus 1 equals 0. Now remember that this is a log equation, but not too difficult to solve. I'm going to make the base visible now. Now you see me, now you don't. So the reason why we want to make the base visible is because to solve this equation, it's easiest to approach it by converting this logarithmic statement into an exponential statement. And now I know that x squared minus x minus 1 equals 10 to the power of 0. Right? So that's how you convert a log statement into an exponential statement. So the base is right here, the exponent or the log is right here. So 10 to the power 0 will be equal to the expression inside it. So we have a little bit of work to do, not a lot. So minus x minus 1 equals 10 to the power 0 is just 1. Please don't rush. I've seen people, especially on tests, just write 10 to the power 0. That's 0. That's easy. I see too many zeros there. No. anything to the power 0 is 1. So this is a quadratic equation, so we have to solve it by bringing all the terms to the left side. And again, I'm showing all the steps. I know this is tedious and annoying, but I hope that can help someone. And let's factor. Hopefully it's factorable. So x and x multiplying to -2 and adding to -1. The only way to break it down is 2 and 1. Let's check and see if the numbers would work in here. Yeah, -2 and 1. And we have either x minus 2 equal to 0 or x plus 1 equal to 0. So that means that either x equals 2 or -1. Whew, we got so many solutions, 3 of them. Now, please remember that whenever we are solving these equations, we need to check and see if the solutions would work. Now, remember that in this case, when you get 2 and -1, 2 squared minus 2 minus 1, that would be a positive number here, okay? And if x equals -1, you have -1 squared minus -1, so that would make +2. And then -1 equals 0, so that would make a 1. So the expression inside will be a positive. So that means that both x equals 2 and -1 are acceptable solutions. So if x equals -2, remember that we obtained it from here. So if x equals -2, then we're still going to see it. If it works in here, -2 squared minus -2 minus 1, that's 4 plus 2 minus 1, 5, to the power of -2 plus 2, that's a 0, so that would be equal to 1. And voila, I think that we have solved the equation. We have checked the solutions. They're all legitimate. So we got 3 of them, x equals -2, +2, and -1 for this very beautiful, very unique equation. Once more, thank you for learning with me, and bye for now.